Hello, everyone, and welcome to our webinar. Today's webinar will be on as actually a first in a series of what's new in 2016. We're doing a sneak preview of what's coming up in our newest version. Now, in this particular webinar, we'll be concentrating on our new options that we have in 2.5D milling, as we had mentioned in the invitation, as well as some new functionalities in our chain geometry, which will make actually creating a chain geometry a lot easier, as well as a very powerful transformation option that we've now added, making transformation a lot more versatile, as well as some other options that we have that we'll show you as we go along in the webinar. So let's actually get started. And of course, this webinar is being broadcasted, so you'll be able to see it on our website as well. Okay, so let's get started. As I said, we'll start off with what we have new, some of the options we have new in 2.5D milling. And we'll start off in our profile operation. In our profile operation, we've actually added now an option for having compensation, where you can have control of where you want your compensation, your tool offset compensation. You can have it on your rough only, finish only. You can have it on the clear offset passes, or you can have a combination of every single one of them. You can have it all on compensation passes, on your finish passes, and on rough passes as well. Now, besides that, we've also added an option of what we call combined wall and floor finish passes. If your tool is large enough to cover the entire floor, we can combine that. Our finish pass will do both floor and finish on that pass. And you'll see in a few moments exactly what I'm talking about. Okay, so let's actually show now the part. And what I'd like to do in this particular part is to actually mill out this step over here. So I have an operation. I'll open up the operation itself, where my geometry is this edge over there. Now the end mill that I'll be using, before I even mention that, let's actually take a look at the width of this step. The width is actually 15 millimeters. Now the tool that I will be using will be a 16 millimeter end mill. And of course we have our levels. Now let's go to our technology. In our technology, as I've mentioned, we've added the option of being able to have compensation on finished passes only, or on compensation finish and on the rough as well. And the compensation on clear offset passes. Right now it's grayed out because I'm not using clear offset. We'll get to that in a few moments. But let's first see exactly what's going on. I have my compensation on finished passes. I have my rough cut, my finish cut. If I take a look at my G code, what you'll see is as follows. My rough cut, which is the very beginning, does not have any compensation. You don't see any G41 in my G code. You only see it towards the end, excuse me, where we have our finish cut. Now, if I want to have compensation on my rough pass as well as my finish passes, I can have it compensation on rough passes. Now let's take a look at the actual G code itself, and you'll see already in the beginning where I have my rough passes, I'll already have my compensation here as well. Now, let's go to my clear offset. In this particular case, I'm using a 16 millimeter end mill, which is actually enough to cover the entire floor because this is 15 millimeters. So we have 1 millimeter on excess material over here. Now, however, when I machine this, I really don't want to go directly with the entire with practically the entire diameter of the tool inside on this material over here. I want to rough it out in a few different passes by using the option of clear offset. Now, when I use clear offset, I'm going to be doing it with a step over of 8 millimeters and with a offset of 8 millimeters, and then stepping over another 7.5 millimeters from the wall offset. In addition to that, I also have a floor offset of 0.5 millimeter. Now, let's do my calculation right now and take a look at the G code. But you'll see that in the beginning, we do not have any compensation because these are the clear offset passes. The compensation will only start a little later on, where I start going towards my rough pass, my actual rough pass itself, and then the finish. Now, if I want to have it on the clear offset passes as well, all I have to do is click over here, and you'll see that already in the very beginning, I'll have my compensation for that for those passes. Now, let's take a look now also at the simulation of this particular operation right now with the clear offset. And this, what I'll be explaining now, is the option of combined wall and floor finish passes. Note at this moment, it's not checked. Okay, so if I were to run my simulation, let's do it actually using Solid Verify. I'll start off my first pass, and as it goes down, let's take a look at my Z level over here. You'll see that's going down to 29.5 millimeters, which is 0.5 millimeter from the very bottom, and then it's going back to the bottom, finishing off that 30 millimeters over there. Then it's doing its next step over and doing the exact same thing, going down to my 30 millimeters to the actual bottom, finishing off the floor. Okay, so in other words, it did 2 passes already over here, whereas the first pass was already machined. Same thing on my last pass as well. Okay, now, since this tool is wide enough that on the finished pass, it can actually cover this entire step over here, what I can do is as follows. I can click on combine wall and floor finish passes, and let's take a look at exactly what happens now. It starts going down, and you'll see it'll go down to its depth of 29.5, where it is right now. Now, instead of finishing off the floor at this point, it'll go back up and do its next rough pass. When it does that, again, it'll go down to 29.5. Now, it's going and doing its finished pass on the wall as well as the floor. So go all the way down to 30, go across, and one pass is only what is needed over there to complete that floor. So now you've taken away those 2 extra steps, and you have one straight pass over there as well. Also eliminating any kind of lines you may have here from that half a step over here that you had it before. So that's what the option of combined wall and floor finish passes does. Okay, let's go on a little further in our webinar. We've added an option now in our pocket recognition to limit the machining depth. Previously in our pocket recognition, if you were working, you did not have any control of your lower depth. It took whatever the lowest depth was, and it always cleared to the bottom floor, obviously on each level, to that bottom depth. Now, the problem with that was that if you had deep pockets, you were not able, you had to use, from the beginning until the end, you had to use a tool that was sticking out quite an amount from the holder itself. You were not able to use short tools because you had no control to limit the depth that the tool was going down to. Now we've added the option of actually being able to limit the lower level. Let's see exactly how this works. I'm going to close this part and load the new part. Okay, now the new part, what I like to do is machine this entire part. Okay, so I'm going to start off in my 2.5D operation. I'm going to use the pocket recognition. I'll choose my geometry, create my geometry, just by clicking on the part. Right now it's finding all the surfaces and the through pockets as well. I'll accept that. Since I don't want it to do the upper floor over there, so I'll go to modify and say exclude top faces. Okay, we'll accept that. Now my tools, I'm going to be using a 16mm end mill that's only sticking out of the holder 45mm. Okay, now let's go to my levels. You'll note that my lower level right now is at -80 because that's the very bottom of the part. Previously, you did not even have this option here at all. Okay, the depth was controlled totally by what the part was, and you could not limit it. But since you were not able to limit it, you could not work with the same type of tool I'm working right now. That's only sticking out 45mm. Now I can actually limit it, and let's go to lower level over here, and I'll click on this surface over here. So I'm limiting my lower level to -40. So I won't have any kind of problem with this particular tool. Now my technology stays the same as my previous options of pocket recognition. I'm going to use my open pocket strategy. Whichever way anyone wants to work, anyone can set up the way they want to. Let's do save and calculate. Let's run my simulation. And what you'll see is that it only went down to this depth over here. Even inside the holes, it did not go more than 40mm. Okay, so now I'm able to use that shorter tool. Now, of course, I have to finish off the part to go further down. Okay, now I have no choice, and I have to use a tool that's sticking out longer from the, sticking out more from the holder itself. So I'll just do save and copy. I'll change to a different tool. Now this one is sticking out 85mm. And in my levels, my upper level now will be where I left off before. And my lower level will be up until the very bottom over there. Save and calculate. Run my simulation again. And it'll just work in those areas. And you can see that in the toolpath as well. Up until here, it worked using the first step with the shorter tool. And when it went further down, you can see that over here as well. So now with this complete control of the depth as well inside our pocket recognition, you have more versatility as far as what kind of tools you want to use as far as short tools, long tools, and in those particular cases. Okay, let's continue now with the with the rest. Let's now talk about our geometry. In our geometry, we've actually made it a lot easier now to create chain geometries, and we've also managed to have less clutter in the area of what to choose in order to create your geometry. Now first, before I even start with that, we have an option for show chain on work plane, where you can actually see the chain not only on the part but on the working plane as well. Now, in addition, as I mentioned before, we have a lot less clutter as far as how to choose our geometry. All we have now, as far as the automatic general and automatic constant Z, we've got rid of that. We've actually combined that into our curve option, where our curve option has the option of tangent propagation as well as constant Z propagation. Of course, we also still have the point-to-point, arc by points, but this now has been combined together with our automatic constant Z and propagation, and our delta Z here as well. Goes together with our constant Z propagation. Now, in addition, we've added what we call a select element and a direction button. You'll see that in a few moments that if I'm choosing a chain, if I start a chain over here and it gets to this point, and you're working on an individual basis of just curve itself, it'll stop here and show you, okay, which way do you want to go, this way or this way? And you just click on that if you want to go in the direction that it chose for you, or you can change direction and it'll go to a different direction as you want. And I'll show that to you in a few moments. It's actually a very cool option. Now, one other thing we've done is that our default in the way our chain geometry is when you start it is our default is with curve as tangent propagation is checked and constant Z propagation is checked. However, in our settings, you can actually decide how you want your default to show. So in our settings, you'll see we have for our geometry curve, all of these settings over here. This is the way I want to have it start, and that's the way it'll start as default every single time. I also have it separate for milling and separate for turning. Whereas in turning, I don't want to have it just tangent propagation and constant Z because then it'll take the entire envelope. In those particular cases, I also have the option of saying up to entity. I pick the first one and last entity, and it creates a chain. Let's actually see how all of this works. Okay, let's close this part that I have over here. And we'll open, I have a few parts I actually want to show this on. First, we're going to start with this part that we saw in our picture before. I'd like to first create a chain geometry going around the entire part. Okay, so let's go to our profile operation. And if I go to geometry, you can see that my default right now are not chosen. Okay, why is that? Well, let's go into my settings for a moment. If I go to my SolidCAM part, if I go to my settings, we have our default geometry settings. As you can see, they are left empty over here. Therefore, you did not see them. If I were to put them on and click on OK, now when I start a new operation and start a new geometry, chain geometry, these are checked as well. All right, now let's take a look how this works. I'm going to start by clicking my first entity over here. Note, you see it propagating on the top plane as well. You can see that checked off over here. And it went all the way around up until this point over here. Over here, it started off as constant Z and tangent. At this point, it went to tangent, and therefore it was able to continue. We had the constant Z over here, and tangent over here. When it got to this point, it stopped because there was no constant Z and there was no tangent. But it's showing you what do I want to choose. I can choose either this one or this one. The default arrow is showing in this direction. Now I can click on the edge itself, and that'll be enough in this particular case. Okay? So now it picked that entire chain. Now let's do this again. This time, I'm going to do it without tangent propagation. I'm going to start from this edge over here. Okay? Now, Note when it gets to this point, it's showing you all the options. It can go this direction over here, this one on top over here. It can go down, it can go across over here, and it's showing as default going in. Now, of course, I can come here and start picking each one individually. But let's actually take a look at what these buttons over here are doing. The ones on my bar over here. Okay? Right now, it's showing it in this direction. This button actually changes the direction. As you see, it's showing you all the different possibilities. If that's the direction I want, I can go to my top button over here, add selected elements, and it'll continue now working without me having to click on the part itself. Just by clicking, and it takes the direction that the arrow is going in at that point. Now, when it got to here, it wants to go in over here. I can always change direction and continue. Just continue again until I get to my very end. Note, I didn't touch any of my elements. Now, in this particular part, it wasn't that critical that I had to use this. But now let me load a different part and see where this can come in extremely handy. Okay, we'll close this part. And just a moment, here we go. Close the part. And I'm going to load my next part that looks like this. Now, what I'd like to do is actually create a chain geometry along the top. Now note, there's no constant Z here along these edges, and we have all small different lines. So if I were to do this individually, let's go to Profile. I'm going to get rid of tangent propagation and constant Z, and I'm going to start off from this edge. If I were to click it individually, I have to go over here and then click on this one, zoom in to this little line over here, click that, click this one, zoom out again, click on that one, this one, bring it around here, catch all those little lines over here. In other words, you know what's going on over here. I'm doing a lot of work, and this is what we had to do all the time. But let's do it now a little differently. I'm going to not accept what I did here. Let's start again from the beginning. I'm going to click on this line over here, the first edge. Note the arrow that it's in the direction that it's going to over here. I'm just going to click on Add Selected Element, this button over here. And as you see, it's just going around the part. Every single time I click on it, it's going in the direction that the arrow is showing me. Now I finished creating a geometry. You can see how quickly that was created. Okay. Now, there's one more option that I did not have in my presentation that I'd like to show you. Let me close this part altogether. And I'm going to load a different part. And in this particular part, I'd like to create multiple chains. What do I mean by multiple chains? I'd like to machine this step over here, as well as this step over here, then this one over here, and then this one over here. So I have to create 4 separate chains to create that geometry. So I'll go to my profile. I'll go to create a geometry, get rid of tangent propagation and constant Z propagation, and I'll start off. I'm going to click over here. And what did I always have to do? I have to click over here and come here to accept it. Okay, go back to my part, click here, go back and accept. Go to my part again, go back and accept. Go back again to my part, come here and accept. This is what I had to do every single time. Now, I've seen customers actually that on their work table, they go back and forth so many times that they have their entire table of in the area of the mouse is completely rubbed off, because all the shining is rubbed off from the table because their mouse is going back and forth as they're going from here to here all the time. So what we've done is we've made this actually a lot easier now. Let's do this again. And this time, we'll get rid of the tangent propagation. I'm going to start off with my first edge. Now, everyone on their keyboard has a button that's called Control, a button that looks like this. Okay, so if you were to hold your Control button, which is what I'm doing right now, I'm holding my Control button on my keyboard, and I'm going to click on this line. Look what's going to happen over here. I'm clicking on this line. A new chain has started. The first one is accepted. A new chain was started. I'll go over here now. Still holding Control. Another chain was created without accepting it. In other words, my Control button is actually starting a new chain and accepting what I did up until that point. Now that I finished, now I can hit my final OK. So I didn't have to go back and forth all the time. All I did was hold my Control button and click on my next element. And that created a new chain, making it a lot time-saving also, and also a lot less bothersome going back and forth all the time. Okay? Now let's continue on. And let's talk about transformation. We actually, and this is actually one of our more powerful options that we've added now inside SolidCAM 2016, where you can do transformation not only when you do translate, not only in the matrix as far as going in X and Y only in the matrix, you can actually go along a specific vector or a specific direction of a different home position. For example, as you can see over here, we have holes going in at an angle, and I'd like to create, and our home position is according to this particular angle over here. So I'd like to create a transform in this direction, going straight, not according to this direction over here, but rather according to this direction over here. So we can do that now inside SolidCAM 2016, and we'll see that in a moment. Now, besides that, we can do that either by home position or actually pick a specific vector on our part itself. Let's actually take a look at how this works. Let's close this part again. And we'll open up this part over here. Now, let's take a look at this operation that I did over here. This operation is on Mach 1 position 4, okay, where this hole is being drilled out. Now, I'd like to have this hole drilled out not only here, but transformed to this hole here as well, to the exact direction. I don't want to create a new home position, okay? Or start figuring out how much to go up and down. I just want to transform it to that position. Now, let's actually go into the operation. And let's go to transform. If I go to translate and matrix, we have our traditional current position XY. Okay? And if I did that, then it will just go according to the direction that this is in, not according to the vector that I would like to go into. So first, let's take a look at the first option. I can go according to specific home direction. If I pick out a different home position, I know that this one over here that I created before, which I can see over here, is the one I'd like it to go according to that particular home position. Okay? Now, I can have it go either XY, YZ, which is not what I wanted to do, and XZ, which is also not the way I want it to go. I'd like to have it go according to my XY vector of that particular home position. Now let's actually do number of copies. We'll do 2 copies, and my distance is 105. And you can see that over here. We'll accept that. And if I were to run my simulation now, let's take a look, not from the top view, but rather from this side view over here. Okay? You can see our first step is in that particular hole over here. And now it's going to come across, go directly down exactly where it needs to go to on that hole over there. Okay? Drilling them both out using the option of transform, but according to a specific home position vector. Now, as I said, there's another option, not only according to our home position vector, but I can say, let's do it according to a specific axis. I can actually pick a vector. In other words, if I were to pick my first vector over here, I can say, let's do it according to this line over here. So I don't if I can't create a home position that I want, I can do it over here. I don't have to. I can do it according to a line. If I have a line that's in the direction that I need. So I'll click on this line. Okay, I'll accept that. And as you see, it's doing the exact same thing. Accept that. Run my simulation, and you'll see that it will do that as well. Now, I like to open up a different part, and in this part, we're going to show you something that many people have been waiting for a long time. When we do a mirror operation in the past, it was always a bit problematic. Why? Because the geometries would be mirrored. That would be the problem. However, the toolpath, if you were working before in climb cutting, when you did the mirror, it would change over to conventional, go in the opposite direction. What we've added now with the new mirror function is that it actually mirrors the geometry but keeps the same direction as far as machining, as far as climb cutting. Let's take a look at actually what I'm talking about right now. First of all, if I were to open up this particular operation over here, I'm machining out around these 3 parts over here. Okay? As you can see, it's going in my direction. It's going to go climb cutting as it did over there, and then go around the part, and then finish, and does the same on every single one of those parts. Okay. What I'd like to do is actually mirror these to get it working on these parts as well, but keep the same cutting direction. So what we've done is as follows. If I were to right click on this particular operation, underneath transform we have a separate option for mirror. Now when I use this option, I can mirror it around a home position if my home position is exactly the pivot point, or I can do it according to a specific plane. Again, when I do it according to a home position, I have the option of choosing which direction. In other words, to mirror it around here, which would be the way I'd want to do it. Okay? Let's choose that. And as you can see, it created a new operation for that mirror. Okay? Let's just do calculate, run a simulation, and as you can see, it's cutting in the same direction. But note, the fact that I have it in a separate operation allows me to control separately, for instance, where I want to start. I can say, let's make a change in our start position, and I'll put this at 0 shift and apply to all. Now when I do that, you'll see that my toolpath will start now in this corner. Okay, and that's because I have a separate operation for this particular mirror over here. Now let me delete this, and I'm going to do the same thing again. This time, I'm not going to do it around a specific home position. I'm going to do it around a specific plane. If we take a look at our planes over here, I have a plane that's actually, at one point, it's actually in the middle. Can't find it exactly at this moment, but I know it's there. Okay, and I'm able to, if I had a plane in the middle, I can actually do it according to that particular plane that was in the middle. Okay, let's continue on down with our with the rest of the webinar. Now there are a few more points I'd like to bring out. One, we have two general points I'd like to mention, is that we have a new dialog for when we create a new part, a new project. If you remember, our old dialog was this window that covered over the part. Now our new dialog is in the SolidWorks tree on the left-hand side. So your part is always visible. Also, we've added the option of being able to see the amount of time each operation takes without having to do simulation. It can actually appear, if you want, inside your CAM tree. Let's take a look at this. Okay. First, actually, let me open up my recent part, the one I just did before. Actually, this one over here, we can see it a lot better. As you can see, we have several operations, and I see the different amount of time for each one of those operations. Okay, now I can control it. If I go to operations, we have CAM tree view, and we have hide machining time. So now I don't see it. If I do want to see it, we go back to CAM tree view, and we click on show machining time. Now this can also be set as a default in our CAM settings. If I were to go to my CAM settings and go into my default CAM tree, we have the option of show machining time, and you see it's checked off over here. If I remove that check, then as default, it will not show it. Now, as far as our new Windows goes, our new start of a project goes, let's take a look exactly how that looks. If I were to start, say, a new project, I go New Milling. You'll see that we have now the window in our left-hand SolidWorks tree. Okay, it's not covering over the part anymore. Now, after I accept it, we've created this, and we're going to create our coordinate system. Okay, so right now everything looks the same. By the way, I'm working right now in SolidWorks 2016 as well. Okay, I'll accept this. And when I accept it, our levels are also now inside the SolidWorks left-hand window over here. without covering over the part. Okay, so let's just review exactly what we've seen in this webinar. First, we've seen the option of compensation, where we can now have compensation inside our rough as well as our finish and our clear offset in our profile operation. We've seen how we can also combine our finish step in our clear offset. Also, we've seen our new ways of creating a geometry that I know will be very helpful for many people, making it a lot easier to create your chain geometry. We've seen the transformation, the new ways, the new options we have in transformation, making our transformation a lot more versatile, as well as the mirror option, where your tool path now keeps the same direction even though the geometry is mirrored. And we've also seen some changes in our interface, as we showed you over here. And as I showed you, that you can also see the operation time inside our CAM tree. Okay, that's the end of this particular webinar. And first of all, I'd like to thank all of you, because many of the changes that we have in every single version, SolidCAM 2015, 16, and as we go along the years, all of them, many of them, I should say, comes from customer requests. We have people out there in the field all the time checking with customers, and when customers make a request, we try to implement it whenever we can. And that's how we build up our program at every time. We always get better and better by listening to what people want. And that's exactly what we're doing with everything that we have in SolidCAM 2016. So again, thank you for your support. But because of you, we have our new features. And also thank you for joining our webinar. Now, this webinar has been recorded and will be available on our website by tomorrow, so you'll be able to review it again. So everyone, take care, have a great weekend, and our next webinars will also be a continuation of what's new in SolidCAM 2016. Take care, everyone, and have a great weekend.